In this video, we're going to look at data. We're going to look at sampling and variation of data and this variation in sampling. So we're going to first classify the data as quantitative and qualitative. Qualitative data is something that you don't measure numerically, like a person's eye color. You don't measure that numerically. A person's hair color. You don't measure that numerically. So that's something that we also call categorical data. There's no getting out a tape measuring and measuring this kind of data. Quantitative data is stuff that you measure numerically. So like height, that's a quantitative measurement. Within quantitative data, we also have quantitative discrete. This is something that we can get by counting. So the number of pairs of shoes you have. You have 2 pairs of shoes, or you have 16 pairs of shoes, or whatever that is. It's a measurement, and we are going to count it. We can say that eyeballs is quantitative data, but the color is qualitative. And then also we have quantitative discrete or quantitative continuous. And these are things like a person's height. So a person's height can include fractions, 5 feet, 10.5 inches, or 3 feet, 3.12 feet, or 5.6 meters. That wouldn't be somebody's height, but that's something that would have decimals or fractions. That's quantitative continuous data. So let's go through some examples to kind of get an idea of what I mean by these different types of classifications. The number of homes a bank repossesses in 4 randomly selected months. So that's something we're going to count. This is quantitative and it is discrete. We are not going to repossess 0.2 of a house. You're either going to repossess the entire house or no house. 500 people were asked the frequency in which they ate chocolate. Never, seldom, occasionally, or frequently. This is qualitative. That their answers are not anything that we can count. We count, never, right? We could assign a 0 to it, but it wouldn't be 0.1. It'd be never, seldom, occasionally, frequently. This is qualitative data. A McDonald's quality control inspector counts the number of fries in 40 individual servings. So you go there and you ask for a large fry and they're just counting how many are in there, and that is quantitative and it is discrete. We assume that we're not going to be talking about a half a French fry, that would be counted as a French fry and not a half a French fry. The license plate of a car. This is qualitative data because we're just literally looking at the license plate of the car, right? So it has numeric and it has alpha. So it's going to have both of those in it, and we're just looking at the license plate of the car. The number on the uniform of a football player. This is quantitative, and it's discrete. You're not going to find football players with 33.5 or 33.3 on the back of their jersey. The temperature in Celsius of Paris, France. Well, this is something that we can measure. So this is a quantitative and it is continuous because we can have decimals within that Celsius. So 23.3 degrees Celsius or 19.5 degrees Celsius. The total weight of sugar imported in the United States each day. This is, again, quantitative and it's continuous data. Ideally, it would be the exact amount each time, but it could be 533 million.5 or something. So that is both quantitative, we are measuring it, and it is a continuous. The prices of 50 randomly selected new cars. This is quantitative, but it's discrete because you have the 30,095 cents, right? They are decimals, but they're decimals that are going to stop, right? They're just going to stop. They're going to be within that decimal range, but it's going to stop. The number of times per week. This is, again, quantitative, and this is continuous. because so you could do something 1.2 times a week. So you've done it and then you partially did it, you haven't completed it that week. So that could be a quantitative continuous data. Data is then, we can talk about it being in two different slots. It's either quantitative or qualitative. We have discrete and continuous that goes with quantitative, and qualitative does not have any subcategories. There's many ways in which you will see data displayed. Some are better than others. So the first thing we're looking at is pie charts. And the assumption with pie charts is that it will be 100%. The pie itself will add up to 100%. And we're going to go in depth into how to do these presentations. Right now, we're just going to talk about what is available to us. And each little wedge represents a percent or the proportion of that outcome to the whole. So as we look at this Foothills College, 28.6% of those who were polled are full-time and 71.4% are part-time. So you can see that the proportion who satisfied one category versus the entire sample that we're looking at, or maybe population. A bar graph is also something that you can use, and this is a different way to present it. It doesn't necessarily have to add up to 100%. And there's the Pareto chart, which consists of a bar graph that is sorted by size from largest to smallest. So the first example is just a bar graph. You can see that we have full-time and part-time. We have the two representations. We have the Foothills, that's the one we talked about earlier, and now we don't have a percentage, we just have the raw number of the students who at Foothills College or high school or whatever Foothills is. You can see that 10,124 students were part-time versus the 4,059%. Now, or 4,059 students, not percent. Now, if you just wanted to look at the data and you wanted to know numeric totals, this would be a great way to do it. If you wanted to know percents, then you'd probably want to consider a pie chart. And then in this example here, that this is maybe the ethnicity of one of those two schools. Let's assume it's Foothills. And you can see that this one is gone from the highest, which is Asian, down to the lowest, which is Native American. And it is organized by the highest quantity first to the lowest quantity last. Now, if I were to put the ethnicity into a pie chart and I did not include other, then I wouldn't have been able to put it into a pie chart. So that's because sometimes you'll put stuff into a pie chart and you won't see that it actually adds all the way up to 100%. So I have other here, and then I also have other here. Now, there's also times that when you're doing percentages, that the percentages add up to 100%. Sometimes they add up to more than 100%. Sometimes they add up to less than 99%. And in that case, the bar graph may be more appropriate versus using the pie chart. So just be aware that just because you can use a pie chart or just because you can use a bar graph does not mean that those are necessarily the best representation. Now let's talk about sampling. Ideally, we're going to get a sample that is going to best represent the population. So there are multiple ways to sample it, and each one of the ways in which we sample this is going to have some bias in our results. And what is bias? Well, bias is that error that can happen that distorts the statistics, which means that it may not always represent the population the best. Every sampling will always have some sort of bias. So what is bias? What kind of biases could you have? Well, you could have the selection bias. How did you select it that could exclude individuals? So as we talk about the different types of sampling, we'll talk about the different types of biases that could happen. And then, of course, there's a non-response bias. So say that you did your sampling and a bunch of people didn't respond. Well, that's going to bias your statistic for that sample, which means that it's going to bias your outputs for representing the population. You have the volunteer bias, you have the undercover bias, you have the volunteer bias. I have that twice. I don't know why. I just really liked it, I guess. And then, of course, we have the sampling frame bias. And this happens when the source that we used to sample isn't representation of the population anymore, or the survey is outdated. All the biases that happen can really distort what it is you're trying to show represents the population. And you really want to think about how best to minimize the bias. And one of the ways that you can minimize the bias is looking at your sampling method. So ideally, we always want to do a simple random sampling. What is simple random sampling? Is that we select our group for our sample in such a way that it has the best chance of representing the population. So we have random sampling. So we are randomly going to select individuals within this population, and true random sampling is done with replacement. So say that you want to find out how people are going to vote in the next election, you would randomly select voters out of your voting polls, right? So you would just randomly call them up, or however you do that, and you would ask them sets of questions. And then you would put their name back in, right? But that is with replacement. That means to return them back in. It makes no sense to continue to ask the same person randomly the same questions. So typically we do without replacement, which means after we ask that person that question, we don't put their name back in the bucket to be chosen again. There's also systematic sampling. And with systematic sampling, you're going to have a list of people's names, and you are systematically going to choose the 10th name, every 10th name. So the one that's listed 10, 20, 30, etc. Okay, so that's what systematic sampling is about. There's convenience sampling. Well, with convenience sampling, say that you want to know whether or not it would be a good idea to raise the taxes to put in a new football stadium. And you are going to stand right outside that football stadium and ask the people. Now, that's obviously going to be biased because you're going to be asking the people who are interested in football, but it's convenient to stand there and ask them whether or not they would like to raise their taxes for a new football stadium. Stratified sampling. This is when you divide the population into at least two different groups. So an example, those who are identified as female and those who are identified as male, and then we will do some other sampling within that group. Or you could have people over 5 feet tall, people under 5 feet tall, however that works out. And then why you'd want to do that is it will preserve certain characteristics of the population. Maybe that's what you're looking for. And then there's cluster sampling, where we cluster them by location. You'll see a lot of that in government and private research organizations. So we're going to cluster them based on maybe location. So that's cluster sampling. In this example, we're going to decide what kind of sampling is in each case. So say we want to find the average tuition at San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What kind of sampling do we have? So the first group of samples that we're going to do is 100 undergraduates taken by organizing the students' name by classification and then selecting 25 students from each. Well, this, because we're classifying them first before we do a random, it is a stratified. So we are breaking them apart by their standing: freshman, sophomore, junior, or senior. The next one is a random number generator is used to select students from an alphabetical list of all undergraduate students in the fall semester, starting with every 50th student we choose until we have got 75. Well, this is systematic. So we randomly decided that we're going to choose every 50th student until we got the bucket that we want. And this is systematic, and maybe the 75 is because if you multiply 75 times 50, that's how many students that are currently on the undergraduate list at this school. Let's take a look at the next one. I don't know why I put that line there, so let me just erase that. A complete random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. This is simple random and probably without replacement, so it is unlikely we're going to put those names back in. The freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick 2 of those years. All students in those 2 years are the sample. So this would be a cluster. We've clustered them by their standing. So we clustered and said, maybe we're going to ask by the random generator, number 1 is picked and number 3 is picked. So we're going to only ask freshmen and we're only going to ask a junior. So we've clustered them by some sort of characteristic. An administrative assistant is asked to stand in front of the library one Wednesday to ask, well, I'm not even going to finish that. We know that's a convenience sampling. And so that is very convenient. Of course, the bias is the fact that they're only asking the people that are going into the library. And maybe the people who are going into the library are going into the library because they're full-time and their cost is going to be more than those who are part-time. So a little bit of bias in there. When you are organizing your data, you have to be aware of the sampling errors and the non-sampling errors. So for an example, a sample may not be large enough. If you have a population of, say, 10,000 and you only choose 20 people, you probably are not going to get a good representation of the population with that sample. And then, of course, there are non-sampling errors, and these are things that are outside of your sampling process. So defective counting device could be a non-sampling error. There's lots of reasons why you could have sampling error. So one of them, of course, is you didn't pick large enough sample size. Another one is things beyond your control. Here's another example. We are going to study, a study was used to determine the age, number of times per week, and the duration, amount of time, the residents use a local park in San Antonio, Texas. The first house in the neighborhood around the park was selected randomly, and then the residents of every 8th house in the neighborhood around the park was interviewed. What was the type of sampling method? Well, we know that the sampling method was systematic. We did it every 8th house. Duration, or amount of time, what kind of data are we going to expect? We're expecting quantitative and continuous. So 3.2 hours is what I spent, or 1.5 hours is what I spent. So that duration of time is a quantitative and it's continuous. The color of the houses around the park, well, that's qualitative. You can't measure color. It's either blue or green or whatever. And the population is the houses in the neighborhood around this park in San Antonio, Texas. Now, every time we do sampling, we're always going to have some variation in sampling. So as an example, you have 16-ounce cans of some sort of beverage, and it's supposed to be 16 ounces. But as you do your systematic sampling method, you take every 10th one off the conveyor belt, you're going to find you have 15.8, 16.1, 15.2, 14.8. You have a variation in what you expect. You expect 16 ounces, but not all of them are going to be 16 ounces. So that's what variation in sampling happens. Now, to minimize this, the sampling variability, which means, say you've got 2 people that are conducting an experiment, and it is an experiment from the same population. If they choose the same sample size and they choose the same method of sampling, they are always going to come up with 2 different answers, 2 different statistics. To minimize this, they'll want to use larger sample sizes. So say their first sample size was 30 and it represents 1,000 people. That sample size that they chose is going to have a larger variation in the sampling statistic than if they would have chose, say, 1,000. So the larger sample size that they have, the closer their statistics is going to get to each other and also to represent the population. And that's it for this video. Make sure that you watch any other videos that are listed as the optional, and we will talk about this in class.